Alright, today we're going to learn about the proportionality of 3D objects. So first off, let's talk about proportionality, right? Remember that if two-dimensional objects are similar, they have the same shape but not the same size. But the corresponding sides are proportional. Meaning that if these two are similar, and let's say that this side here were 2, and this side here were 4, and this side here were 1, well, in order for them to stay proportional, that means that this side here would have to be 2. And the way I can figure that out is that I can make a ratio of the two sides, like this. 2 over 1 is said equal to the ratio of the other object, 4 over 2. And we can reduce this down to 2 over 1 by dividing the numerator and denominator by 2, which would give us 2 equal to 2. And that's how we would know that two-dimensional objects are similar or proportional to each other. Now, the same thing can be said about 3D or three-dimensional objects, right? So let's say I had 2 cylinders. So let's say I had 2 cylinders, and one of them had a radius of, let's go with, 3, and let's say that this one had a radius of 9. Okay, so if I know that the height of this cylinder here were 3, how would I figure out what the height of this cylinder were, right? And remember, if they are similar, they are same shape but proportional sides. So I can go ahead and write a ratio comparing the two sides of radius and height. So I can say that this is x, and I can put 3 over x is equal to 9 over 3. And here we can use cross multiplication to figure out the missing dimension. So 3 times 3 is 9, x times 9 is 9x, and then I divide both sides by 9 to get x by itself, and I get 1 is equal to x. So this dimension is 1. So that's how we can use proportionality and the concept of similar objects to help us find missing dimensions. Now, we can also do the same thing when we know the surface area or the volume of two objects. For instance, let's say I had 2 cylinders. And I know that the height of this one here is 6. And I know the height of this one here is 4. And I know the surface area of this cylinder is 180 inches squared. But I don't know what the surface area of this one is. I need to find that surface area. So how do I do that? Well, the rule is this. If you take the surface area of one object and divide it by the surface area of the second object, it will be equal to the dimension. So in this case, we could say the height. So we could say h of A divided by h of B to the power of 2. So let's use that to help us find the surface area of the second cylinder. So I know that the surface area of this first cylinder is 180, and I'm going to say the surface area of the second cylinder is x. So now I'll plug it in. 180 over x is equal to, okay, height is 6. And now remember, it can be height, it can be radius, either or, whatever you have. And I'll put over 4. And now we'll go ahead and raise this to the power of 2. That gives us 180 over x is equal to 6 to the power of 2, which is 36, 4 to the power of 2, which is 16. And now we can go ahead and use cross multiplication to help us discover what x is equal to. So 180 times x, or times 16, that gives me 2,880, okay? And then 36 times x is 36x. Divide both sides by 36. And we get 80 inches squared as the surface area for the second cylinder. So that's how we use the concept of surface areas to help us find either missing dimensions or the missing surface area. And remember, area always is having the unit to the power of 2. So that's how you can memorize that this is going to be to the power of 2. Now, let's look at another one. So again, let's say we have 2 cylinders. And we knew what their radius was. We can say that this one had a radius of 4, and this one has a radius of 2. Okay. And then let me see here. And let's say that this one has a volume of 150.8. And I want to find the volume of this cylinder here. So the rule is this. You can take the volume of one cylinder divided by the volume of the second cylinder and will equal to either the radius or the height. In this case we have radius, right, of the first cylinder divided by the radius of the second cylinder, all to the power of 3. And like I said, the last example was surface area, that was to the power of 2. Now we're talking about volume, and volume is always to the power of 3. So now we can go ahead and use this information to help us find our missing volume, which I'm going to say is going to be the variable x. So we'll plug it in. You have 150.8 divided by x is equal to 4 over 2 to the power of 3. Now, we'll go ahead and raise this to the power of 3. 4 to the power of 3, that gives us 64. 2 to the power of 3, that gives us 8. And at this point, you could just simplify this and say it's equal to 8. But let's keep it simple, right? Because we're already using cross multiplication as a method. So we'll cross multiply here. 150.8 times 8. That gives you 1206.4. And it's equal to 64x. And then we'll divide both sides by 64 to get x by itself. And when we do that, we get 18.85 is equal to x. So that's going to be 18.85 cubic inches, right? So put inches cubed, right? Inches cubed. And that would be our answer. And that's how we use proportionality in 3D objects to help us find missing surface areas or missing volumes, or finding the dimensions of those 3D objects when we know the surface area and the volume, but not the dimensions that we're looking for. And that's it. All right, I will see you kids next time.